Hi folks, it's Mr. Defy once again, and welcome back to video 2 on how to get slope from a line. I want to start this example a little differently than I did with example 1, in that rather than counting squares and focusing only on that method of getting the slope, I would like to show you another way to derive the slope, which in some cases is probably more practical and a little easier at the same time. Okay, so let's go ahead and get right into it. So here we have a line AB, a line that goes through points A and B. And the first thing you want to notice is the direction of this line. So imagine that you were going on a hike. And if you were going on a hike, this line would represent going up a slope or up a mountain or hill, right? So bearing that in mind, the direction of the line already tells you something about the type of slope you're going to get. So I already know that this is going to be a positive slope because it represents going up, just like on a hike. So with that in mind, I'm going to start by putting my order pairs for point A. Point A is at, and maybe I should move it to the other side. So point A is at -2 and +1, whereas point B is at -3 and -3. So if I use my input-output table, my XY table, it would be the following. For point A, it would be -2, 1, and for point B, it would be -3 and -3. So what this does, it helps me see the way that these numbers are changing. In a numerical way, I can see that 1 turns into a -3. The only way that a positive number can become a negative number is if it becomes more negative. So for 1 to turn into a -3, it has to go down. Oops, sorry about that. You have to go down 1, 2, 3, 4. This is level 1. This is level -3. And to cover that distance from 1 to -3, you have to go down 4 levels. And the action of going down means that this becomes a -4. Okay, now we do the same thing with the x's. So a -2 going to a -3, I'll get rid of that. To go from a -2 to a -3, in other words, to go from where point A is to point B along the domain or the x-axis, you would just have to jump 1 step to the left. So it's 1 to the left. So from here to there, it's -1. Okay, that negative represents going left, where numbers get more negative. So my slope, my change in y over my change in x, would be a -4 and a -1. Again, this means I went down and I went to the left. Now, if you can divide, you should divide. If you can reduce or simplify, you should reduce or simplify. So my fraction, -4 over -1, becomes just a +4. And what this means in graphical terms is that if I wanted to go from one point to any other point on this blue line over here, I would simply have to go 4 steps up and 1 step to the right. Okay? But I can also do it in a different way. I could also, I can also put negatives on these, and what this would mean is that instead of going up and right, I would then go down and left. Okay? So I'm not changing the idea of the slope. I'm changing the location where I end up on the line, depending on which direction I choose to take. So up and right or down and left. And I want to demonstrate that for you over here so you can see exactly how this plays out. I'll get rid of all these writings here so it's nice and clear. Okay, so going with 4 over 1, a slope of 4 over 1, what that would mean is if I pick any point, like for example this one over here, I'll call it point H this time, going up 4, 1, 2, 3, 4, and going to the right, 1 to the right, gets me to point, let's say I. See, I snap back onto the line again. And if I wanted to go the other way with -4 over -1, so -4 over negative 1. What that would mean is if I pick any point, I could start with point H, but if I went down 4, I'd run out of space, and I don't want to do that. So I'll pick a point that's higher, like this one over here. Let's call this point M this time. So if I wanted to go with this direction, negative 4 over negative 1, I would then go down 4 times. So 1, 2, 3, 4. 4 down. And that would mean I would have to then go 1 hop to the left, 1 hop to the left. And I end up at point, let's say, J, for example. Okay? So but I snap back onto the line again. And that's the idea, that's the idea of slope. It's a set of directions that takes you from one place to another place on the same line. Okay, now this is kind of the idea of slope using counting, which I said I wasn't going to do, but I ended up doing. What I want to focus on is how to get this same conclusion, the same 4 mathematically. So I want you to look at the words change up here. The words change have to do with relocation in terms of a graph. You're changing your y numbers. As you can see over here, I was at negative 3, but now I'm at negative 2 and positive 1. So my y numbers had to have changed somehow from here to there. And the idea is to represent this mathematically rather than just counting squares. So here's how this would work. I want you to think about change in terms of going to the store and receiving change after paying for something. So to get change, the cashier would have to subtract the amount you give with the value of the item you buy, which means we're going to do the same thing here. And this is the way it goes. Change in y, change in x, and this is mathematically. So I better write that down just so it's very, very clear. So mathematically, which everything is mathematical, but this is involves numbers rather than just counting squares. So mathematically, my change in y, it can be represented as going from 1 and ending up at negative 3. Okay? The word change is represented by a minus sign. So if I put a minus sign right there, that right there represents the idea of changing. Okay? Changing. So 1 is changing into a negative 3. So how much is a 1, by how much is a 1 changing into a negative 3? That's what this statement is asking. It's really asking that. By how much is this changing into that? And we do the same thing with the change in x. So we want to take the same direction. So if we started with 1 going to negative 3, with the x's, we start with negative 2, because that pairs up with this one. From negative 2, we end up at negative 3. And just to make it really clear, this negative 3 is this one over here. Just follow this marker on the screen you see. It's this negative 3 that I'm talking about, not the highlighted one to the right, because that's your y, your output. We're doing the inputs now, the domain. Okay, so getting back here. So again, I want to represent, how did a negative 2, by how much did a negative 2 change to become a negative 3? And so when you're faced with a setup like this, you want to remember one thing. Parentheses are our friends. They help to create separations, which our eyes are much better at understanding, and our brain is much better at handling. So when you create a simple separation with parentheses, your brain sees, oh, I have a negative of a negative. So I know what to do with that. A negative of a negative, well, the opposite of a negative 3 is a positive 3. So this then becomes 1 plus 3. The opposite of a negative 3 is positive 3. So now this becomes negative 2 plus 3 down there. Now I have to simplify this. So this is 4 over negative 1, over positive 1. And if you divide 4 by 1, you just get 4. Oh, sorry about that. I keep tapping things. And it's not going away. There we go. You get of 4. All right, so that is my slope, which again, I got over here, if you notice. I got that before, but we got this before by counting. Whereas over here, we got this by using the idea of change, representing subtraction, okay? And we get the same idea. So this represents, as a fraction, well, I already wrote it over here. This would be going up 4, going to the right 1. And as I already demonstrated, it works when you go from one point to another. You go up 4 times, right 1, or you can go down 4 and left 1. Either one takes you right back to the line, but somewhere else on that line. And I hope this helped. So this is the method for getting slope or rate of change using a more mathematical method. And both methods work just fine. The only limitation is that when you're doing counting of squares, if your ordered pairs are really far apart by the hundreds, then you're not going to sit there and count hundreds of little squares just to get the slope. So mathematically, this is a much quicker and faster way of getting the slope, especially when you don't have a graph to look at and you only have ordered pairs. And we're going to take a look at that example in another video. So hopefully this helped. Please leave a comment. As always, stop by, check for other videos coming up in the near future, and I will see you again next time. Bye-bye.